Kia ora Year 13. This is my third go at making this video. I've been having trouble getting the sound to work. So if you could please leave me a comment just letting me know if that's working okay, that'd be great. I'm going to do two examples in this one. So go watch the first verifying DE's video if you don't know what I'm talking about. They're going to be second order differential equations and a little step up on the first video. So the first one we're going to look at is this. We'll look at y equals root x plus 1, and we're going to show that it's a solution to the following DE. Right, so what we want to do is to take the proposed solution, find the first derivative and the second derivative, and then substitute those in to the DE. So pause the video and go do that now, and let's see what we get. Well, the first step is to rewrite that expression with an exponent instead of a radical sign. And now we're going to differentiate. So we'll get dy by dx. We're going to do the chain rule, so it's 1/2 x plus 1 to the power of negative 1/2. Now I've got to check the inside function there. The derivative of that is just 1, so that's easy. And now I do the second derivative, so we bring down the power, we get negative 1/4 times x plus 1 to the negative 3/2. Right, just doing the power rule and the chain rule. Next thing I'm going to do is substitute those into my differential equation here. I'll start on the left and work through to the right. So we'll do that on the next slide. Alright, so first thing we'll do is we write out what we want to substitute into. 2y squared d squared y by dx squared, and so on. And now we start substituting. So we get 2 times x plus 1 to the power of 1/2 squared times negative 1/4 x plus 1 to the power of negative 3/2 plus dy by dx 1/2 x plus 1 to the negative 1/2, and that equals, let's just erase that. Okay, so negative 1/2, cleaning up the coefficient. This is x plus 1 times x plus 1 to the negative 3/2. We could put a power of 1 in there, plus 1/2 times x plus 1 to the negative 1/2. So now, organising that, we get negative 1/2 times x plus 1 to the power of negative 1/2 plus 1/2 x plus 1 to the negative 1/2, and that equals 0 as required. So we've shown that that equation, the one we started with, y equals root x plus 1, is a solution to that differential equation. Okay, on to the next example. Okay, this next example is practice with the product rule. So we want to show that y equals x times e to the 4x is a solution of this. So the steps are the same. First we differentiate the proposed solution. Then we do it again and we substitute it all in. So let's have a look. Dy by dx, product rule. So this is the first function and this is the second function. So it's x times 4e to the 4x, right? The first times the derivative of the second, plus the other way around, the second e to the 4x times the derivative of the first thing. So taking out a common factor, I get this, e to the 4x times 4x plus 1. Now it's quite nice to factorise that because we're going to have to differentiate again, and it's going to be quite fast to do. if we've set it up like that. So d squared y by dx squared. This is the first function, this is the second, so it's going to be product rule again. So it's the first function, e to the 4x times the derivative of the second, 4, plus the second function times the derivative of the first, so 4e to the 4x. So I'm doing chain rule on that, probably without thinking about it by now. Okay, so what have we got? Well, we've got e to the 4x times 4 plus 16x plus 4 here. So there's the 4 times that, gives me the 16x, and the 4 times 1 gives me that. So my second derivative is, well, let's take a common factor of 8 out here. 8 times 1 plus 2x times e to the 4x. Right, so look at what I've done there. I've just taken that 4 plus 16x, and I've put the 4 and 4 together to get 8, and I've factorised again. Now you don't have to do it that way at all. I'm just showing you one way. You could work with it being 8 plus 16x, and it will all still come out in the wash. So next what we're going to do is we're going to substitute this expression and this one and y in, and we want to show that we're going to get 0. So I'm going to do that on a new slide. Okay, so we start as usual, we just write out the dE. And now we substitute. So we've got 8 times 2x plus 1, just reordering that a tiny bit, times e to the 4x, minus 8 times 4x plus 1, e to the 4x, plus 16, and now I substitute in what y was. So y was x e to the 4x. Right, now we want to show that that's 0, but we don't just want to write equals 0, right? Because that isn't really communicating all of the steps. So as I said before, don't get frustrated and try to go too fast. If you're doing this type of thing in an exam, we want to see that you really are showing the process. So we're going to take out the common factor right through of e to the 4x, and we might as well take out the 8 since we already factorised. So we're going to get 2x plus 1 minus 4x minus 1. So be careful there, you've got a minus times those things. And then the plus 16 becomes plus 2. Oh, pen just changed colour. Okay, let's change it back there. So now I've got 8e to the 4x. Now I've made a mistake there, haven't I? I've missed out the x. That should be 2x here, not 2. 8e to the 4x times, well, those go 0 plus 0, so something like that, which is just equal to 0 as required. Okay, so we're done. If you're working out of the old Delta book and you're aiming for excellence or scholarship, there's some quite challenging extension exercises, more for the algebra than the differentiation, but you might want to have a go at those as well. And this exercise in Delta is a really good one just to work through lots of examples from. So that's exercise 23.3 in both the old and new book. Thanks for watching, and please leave me a comment and let me know if the sound is going okay.